Good afternoon, everyone. My name is Susanna Sanislo, as Phil said. I teach at Valparaiso University, a smallish school in Indiana. And I really know nothing about industry and government, so I will learn a lot, hopefully. And I hope this won't interfere with everything. We do have a very nice panel today. The first to my left is Bill Christian from the National Security Agency. Then we have Martin Lacasse from ExxonMobil, and Rick Lageson, who is currently at University of Illinois, but he actually wrote a book about how to get a job in industry. So maybe you can find that useful. And as a starter, I would like to ask the panelists to say a few words about their experiences, their advice, their career path, and after a few minutes, we will open up for questions from the audience. Thank you.
Sure, I'll give the fast and boring version. Went to undergrad in Maryland, University of Maryland, Baltimore County. I went to Rice for my PhD. I originally majored in math because I didn't know what I wanted to do, so I figured I'll just do that until I figure out what I really want to do with my life, and that's what I'm doing still. I taught for 4 years. I originally wanted to get a PhD because I wanted to be a professor, and after 4 years I realized it wasn't exactly what I wanted, and I wanted to do research that I knew was going to be applied and valuable. And at the same time that I was making that decision, someone from NSA said, "Hey Bill, when you're ready to leave academia, you should give us a call." So that was 14 years ago, and clearly I'm still enjoying it. We are hiring, and if you don't even need to read that book. Although it's a good book, but you could talk to me right now.
All right. My name is Martin Lacasse. I'm a native French Canadian. I studied chemistry first, in full disclosure, and then I switched to physics, and I graduated in physics. And then I did a postdoc at Princeton, and from there I got a job offer from ExxonMobil Research and Engineering. Back then it was only Exxon Research and Engineering, and now I'm perceived as a closeted mathematician. So I feel like I'm working on PDEs, and I think the only thing I do differently than what mathematicians do, I use units and not. I would like to maybe take a little bit more time. Maybe I'll be boring too, but or not. So this is who I am, and I want to say why I'm here. So we have the industry. So I find it a little bit unfortunate that you guys have to select even now between academia and the industry just by having two rooms at the same time. I think you shouldn't have to select things that early. And for me, when I selected it's not like I'm going to the dark side or the bright side. I first thought, well, if I want to go to academia, maybe having some experience in the industry, that would be good. And I was a joint postdoc with Exxon back then. And then I ended up being caught at my own game. So why having the industry here? So a few numbers for you. So last year, there were, I think, 1,900 PhDs in physics that graduated in the US. And last year, there were 357 faculty positions. I think you're smart. You can do the math. That means what happens to those other 1,900 minus 357, which I cannot do. So I think the question is very, maybe it's in the book, which I haven't read, but I mean that's sort of I would say a fact that is facing a lot of academia, but that we don't address directly, and that's what's being said here. We don't prepare the students well enough, and I think in some places it's a little bit like I remember my own advisor was telling me, okay, son, I got a job, and I'm going to teach you how you're going to be able to get a job in academia, but never was this window towards the industry. And I hope this window, and that's why I'm here, and that's why we're trying really, really hard within ExxonMobil to have to broaden that window. So that's why I'm here from an industry standpoint. Now, why am I here at the Math Alliance? I'm here because we do believe intensively in diversity. Diversity of skills, diversity of genders, diversity of thought. And unfortunately, it's very difficult. So we had a very static way of hiring in the past that could not address the challenge we had in terms of fulfilling the positions we have. And what are those positions, the positions that we have? So I'm from the oil and gas industry, I need to say it, the energy industry. And the energy industry is currently facing tremendous challenges. I mean, there's a climate change that is there. There's an increasing population. Will be 9 billion people on Earth within this century. We have a fraction of India and Africa that is without power, still cooking with biomass. So if we want to bring all these people to this decent standard of living, we need to provide energy, because energy correlates with the standard of living. So now the dual challenge we have is, how do you bring more energy in the world while decreasing the CO2 emission? So there are a lot of solutions on the table. So we're looking at carbon sequestration, we're looking at biofuels, we're looking at new material, we're looking at process intensification. How do we transform this fossil fuel without emitting as much as we do? So these are all challenging problems in terms of skills, in terms of ideas we need, and how do you put it all together? So there are a lot of people we interview, and they come and they say, why industry versus academia? And what I tell them is that academia tends to be a solution-rich environment, while industry is a challenge-rich. I used to say problem-rich, but my supervisor didn't like this. But it's a challenge-rich environment. So these are humongous problems that we all need to address. And we recognize that there are solutions in academia, and that's why ExxonMobil started with something called the Energy Alliance. So we have like a specific alliance with Stanford University, with Princeton, with now National University of Singapore. We reach overseas. We do University of Texas in Austin. So we have very broad agreements, and we're talking like several $1 million a year for some of those universities, and trying to interact better with universities and bring our problems to academia, so that people not only in academia can see what we do, but also students can see what it would be like to be in academia. Going back to diversity, we're also working all the way through the pipeline. So ExxonMobil Foundation goes to STEM, and we're trying to initiate people from the middle school to high school, and now we're trying to, and that's the reason I'm specifically here, we're trying to reach out to professional organizations, and how can we enhance the presence of underrepresented minorities and women in science. And one thing that, it's not only to me, for us to do something for you, you say, okay, do you have a job for me? I have also a request for all of you. So I was talking to a colleague regarding diversity, and his name is Moba, and I was saying, oh, I'm going to this Math Alliance. And he was telling me, well, maybe you need to start much earlier than that. I said, what do you mean? He says, well, my daughter loves math, and she's in elementary school now, and all his friends, or her friends, are telling you, no, you're so weird. Why do you do that? So if we don't change the perception, really at the very young age, we're creating biases that are already there. And you're much closer to that generation than I am. And my request to you is to your cousins, to your the little neighbors that you have. I think you have a role as a mentor as well, and to mentor those young kids and be a role model for them. And I think that's a very important role that you should not forget. You should be sensitized by the very fact that you're here, but I think you should play that role and take it very seriously. Sorry I took so long.
Thank you.
Hi, my name's Richard Lorgeson. I grew up in New Zealand, and the first place I ever came in the United States was right here, St. Louis. I landed over at Lambert Field on a direct flight from Europe. I happened to be flying through that way. Got my PhD here at Washington University in 1993. Some of you might have been there already or will go tomorrow during the conference. It's a lovely campus here in St. Louis. After a couple of postdocs, I came to the University of Illinois, which is about 180 miles drive away in central Illinois, where I do research in partial differential equations and harmonic analysis. So I began as graduate director in 2012, and at that time about 10% of our PhD graduates would go to careers in industry, straight out to the PhD. Of course, some people also transition later after first taking an academic job. Well, that 10% has now grown to 30%, and we want to see that go up to 40%. And okay, so why do we think that trend is healthy or a good idea? Well, two reasons. There's a push and a pull. So the push, Martin has mentioned already that in mathematics, the number of PhDs given out annually in the United States is more or less doubled in the last 16 years. So there are a lot more people getting PhDs in mathematical sciences, that's math and statistics, biostats, than ever before. And meanwhile, the number of tenure track, full-time, permanent academic positions has been flat at best. So that's the push side. Now the pull side is that for many of our students, and many of you here today, you have intellectual interests, personal qualities, you have family situations that really just fit better in industry and government. So if you want a job in industry, you can, with pretty high probability, pick any major city around the United States, go there, and find a satisfying position. That's certainly not the case in academia. In academia, you will have to go where that one or two job offers, where they might be, anywhere around the country. The good thing is that the present day is the best ever of all time job market for mathematically trained people going into industry and government. The demand for people with advanced skills and the ability to learn independently and work in an interdisciplinary team has simply never been higher, and it runs across a broader range of industries and government agencies than ever before. So what I tell our students is, yes, it's a challenging academic job market, and it's the best time there's ever been to get a PhD in mathematics and get a satisfying job that will pay well and offer you flexibility throughout your career. So you should just choose your career path appropriately, think about what you want to do, plan ahead during graduate school, just like you're doing now during your undergraduate time. You're planning ahead, you're getting involved, networking, figuring out what the next steps are. Many of you have done REUs, so these are the kind of things you want to do in graduate school as well. So to help students chart that path, Rachel Levy, who's at the Mathematical Association of America, and Fadil Santosa, who's at University of Minnesota, and I wrote this book that has been mentioned. Rachel's currently in the other panel. She's on the other panel right now, so she can't be in the room, but she's here at the meeting. And we will draw on, I will draw on the advice that we've put together in this book in my responses during today's panel. I'll also be at the Career Fair and the REU Fair this afternoon with Rachel. We'll have a big banner, you can't miss it. The logo on the banner is sort of more or less like the logo on the book. You'll spot us. And our advice is free, and our advice is fairly reliable. So I hope to talk to some of you later on today as well.
Thank you very much for the panel. So, questions? And I know that the panelists talked about PhD people, so once you get a PhD, what you can do. But even if you don't plan that, you can ask your questions.
Yes, hi. My question has more or less to do with, okay, I guess I'll stand up. My name is Juan Escobar. I'm a second-year master's student at Cal State LA, currently applying to PhD programs. Up until this point, I've been more of a pure mathematician, but I don't want to, limit my possibilities to just do a PhD in pure math. But if I did, would that limit my chances into finding a job in the industry? And if not, what are the extra steps that a pure mathematician would have to do to be more competitive in the world of industry?
So I think that's a great question. Unfortunately, you have to ask that question. I have been long of the mind that the difference between pure mathematics and applied mathematics is just the motivation. Applied mathematicians are motivated by solving some particular problem. Pure mathematicians are just motivated by doing math. And so that's pretty much the difference. If you talk to a number theorist, they think they're applied. If you come into my office, they'll think that or talk to number theorists, they'll think they're pure mathematicians. If you come into my office, they'll know that it's an applied field. And so it depends on what you want to do. So just generally speaking, right, so I did combinatorial optimization. Obviously that's applied, so I could probably work in lots of places. If you do number theory, if you do number theory because that's what you want to do, then it obviously is limiting the number of jobs that you have available to you. So that being said, a lot of, as Richard said, this is a great time to be a mathematician looking at industry, because industry is starting to recognize, as NSA did years ago, that mathematicians really are kind of like Swiss Army knives, and it's really the mathematical thought that distinguishes a mathematician from other fields. Like, we can look at a problem, we can solve the problem, and then we can step back and generalize and write the theorem that says this is going to be the solution every time we have this situation. So I would say that's really what you want to sell, the mathematical thought. There's also, and I'll let the others speak to this, there are also programs that try to convert pure mathematicians into particular breeds of applied mathematicians. Particularly data science is really popular, and so there are some like post-PhD programs that are stints that will train you, like give you a deep dive into data science. MSRI has programs, and some of the labs have these things. So I don't know if that fully addressed it. Yes, it's going to be a challenge instead of going into applied, but it's not impossible to make the transition.
Okay. My response to that would be, sometimes we overthink the topic of the research you're doing. To me, in my mind, once you get a PhD, you might be an expert in one thing that you did because you're the world expert in the tiny little thing that you did, but very, very deep. But to me, you just got a degree in being a professional learner. That's what a PhD is. And what I tell the people that join the research lab where I am, you're going to do a new PhD every 4 years or 5 years, because the topics change very rapidly. Oh, you're working on this now? No, now we're going to change topic, and you're going from scratch. That's what makes it so interesting, because you reinvent yourself every 5 or 6 years in some industries. So to me, that having established that you are a professional learner, and we don't fool ourselves. If you do a postdoc, I just realized when I did a postdoc, is like, when am I a doctorate? Because I got my degree and I'm immediately a postdoc. So there's a fraction of a second where you're a doctorate, but then it goes away immediately. You become a postdoc. So enjoy the time when it passes. It's like a green light flash or something. So if you decide to do a postdoc, so let's maybe rewind a little bit. During your PhD, I would say if you have a plan to go to the industry, pick your advisor wisely. Because some professors have a career in working on very important topic, but that would be demonstrating a proof for something that maybe some people might care in 20 years. But others will be, well, they still demonstrate that proof, but they also have connection with the industry. They also have some problems, or they show some relevance. So for you, it's a good way to be exposed to what you could be doing in the industry and have the network, start your network right there. Picking the university as well, if you have any department that would be, I mean, one example is the IMA in Minnesota, where you're in the math department there, but they have programs, they have a lot of different initiatives that connect the mathematicians with different industries, and there are connections to bio now. There's, as was mentioned, data science is very big. Everybody's using deep neural network, but nobody has a clue why they work. So there's a lot of work to be done in this area, and that's an emerging area. And if you pick the topic and your advisor wisely, I think that's probably the most important decision. More the advisor than the topic itself.
I want to contribute a few thoughts. One is about sort of labels and how we conceive of ourselves. So I've tried to stop using the words pure and applied mathematics actually in recent years because I don't think it really captures what we're doing as mathematicians, and the more labels we have, I think the more we sort of cut ourselves off from possibilities. So I suggest think of yourself as a mathematician or a mathematical scientist, if you want to be a little broader. Think about what you enjoy doing. So do you enjoy coding, programming? Like if you've got some problem that you know can be solved by writing a short program, do you do it? If so, then you've got the beginnings of the kind of skills it takes to turn yourself into someone working in industry or government. Because you definitely will need at least some amount of coding skill, right? So you're not being hired as a computer scientist, but you've got to be able to code up that idea you had that you want to tell your boss or your supervisor about. Another pair of labels actually is so academic positions versus what? Well, people used to say non-academic, but as you can imagine, that's sort of a negative descriptor. So the reason this is called the Big Jobs Guide is big as an acronym for business, industry, and government. We could have called it the IG Jobs Guide, but the publisher thought big sounded better. So big, business, industry, and government. Business maybe more the office-y kind of jobs, industry perhaps more with something's being made or physically done. So you're going to need coding skills, and an internship is a great way to get into industry. And so I was just jotting down a few areas that students in our program have gone from to do internships: graph theory, low-dimensional topology, probability, representation theory, ergodic theory. These things are not naturally applied math areas, but students from those areas have all gone and done internships, got experience, and got excited about the possibilities once they did it. So there's sort of this potential barrier often surrounding a mathematics department. You have to get over or through that potential barrier. Once you do and you start to realize you can succeed and enjoy it, then your career options really open up. So go for it.
Hi, my name is Adrienne Sands. I'm a fourth-year PhD student at the University of Minnesota. And one thing I've been struggling with is trying to determine whether I fit in more in an academic setting or in an industry or government setting. I see a lot of similarities between the two. You know, there's a focus on scholarship, of creating knowledge, creating information. And so when I try to evaluate which would be a better fit for me, I don't really know which would be the right area. Then you try and say, okay, where do I fit in more? Where are there more people like me? And unfortunately, as a minority student, that's not really a criteria that I can use to evaluate either option. And so I guess I was wondering what, aside from, I mean, there are very few. So I guess I was wondering what soft traits do you see working for students who are more so geared towards academia versus ones that are more so geared towards industry or government?
You wrote the book.
So thanks, Adrian. A good person for you to talk to at Minnesota would be Fadil Santosa, who is one of the authors of the book and has many years' experience guiding students. I'd say just a few things and then pass over to the others. So one, how self-driven are you? Do you like to have your project that's really yours and you develop the ideas and you're going to pursue it? Or do you actually enjoy sort of joining a larger team project where there's an external goal that you're trying to accomplish? Another classic distinction would be sort of immediate versus deferred impact. So the impact of any particular theorem that I might prove, if ever, is likely to be pretty far down the line. But if you're working in industry and government, the timelines are usually shorter. Martin can tell us more about that, and the results are more tangible. So you just try to size that up. And then the other thing is, like when you choose a graduate program, there might not be just one right answer. So maybe you'd actually be happy in both. And so don't sweat it too much, so long as you are happy doing what you are doing.
Maybe I'm not in full agreement. I don't see any difference between the two. I think if you're good, if you're driven, you're going to thrive in either environment. In terms of timelines, you can pick sectors where the timeline won't be as tight. And I'm sure when your grant proposal is due next week, you have a timeline there as well. And I've seen I have friends in academia, and they spend the weekend writing grant proposals, and they're available on their phone 24/7. So I think if you are driven, if you're talented, if you believe into yourself, either of those two environments is going to be very fulfilling. And I think maybe one characteristic of the industry versus non-industry, and again, I'm not speaking on behalf of all industries. I mean, there's a semiconductor industry, there's a government which also hires a lot of mathematicians. There's the insurance industries and forecasting, the Googles and all the data mining of the world that also have very different requirements. I think probably the most striking difference would be on the expectation for change. And some people in academia create their own change, but if you're adverse to change, you might create a bubble somewhere and be comfortable and stay there for longer. And the time scale might be a little bit longer in academia. But that doesn't, you can also redefine it the way you want. If you want a shorter time scale in academia, I've seen people up left and right and change job or even change topic, or change topic as they change student and reinvent themselves. So I think we have much more freedom and will to determine what life looks like once you're facing it. So you decide to write a book, right? And somehow you could do, the possibilities are always in front of you, and regardless if you're in the industry or in academia, I think you can always be define a job that would be fitting for yourself. So now going back to specifically to your question is how do you recognize yourself? How do you prevent having the imposter syndrome, essentially, right? And I think that's sometimes a self-created problem. You need to, through assertion and through confidence, you need to say, well, no, I fit here. And I'm also first generation, so I can really attest to that. My first year in college, you always ask yourself, am I in the right place, or am I fitting here? I think that's something you need to work on yourself and be more assertive and see this as a strength and a difference. You're bringing something completely different from others. And this perspective, more and more, is becoming appreciated. And we see any business doing innovation, and that's not only the oil and gas industry. You could argue that innovation takes place, but not at the same pace as elsewhere. But in all research where innovation is required, the key word now is we need diversity. Diversity of thoughts, diversity of skills, gender diversity. So we need to have, we don't want to have all the same people around. So somehow it's counter to what you're suggesting, that you would like to be in an environment where everybody looks and think like you. In the industry, we would like people to be all of different thoughts and all of different backgrounds. So you fit, we need you, so.
Yeah, I'll say there are obvious differences between academia and non-academia and industry or
No, I
government.
would say
and
industry and non-industry. That sounds
Yeah.
better.
You know, in academia, there's teaching, right? So it's basically teaching, service, and research. And I think you just have to think about how much of those do I want? If you really don't like being in front of the classroom, probably shouldn't be in academia. You know, if you just love being in front of the classroom, then academia may be the right place for you. But even then, I would say, so at NSA, we have what we call the National Cryptologic School. And so we have classes that we offer to our workforce during the workday. And those classes are taught by the experts in our field. So people who I work with, people in my office, they run a data science class. Other people run a cryptography class. We have a programming class. And so often industry will allow you some of the things that academia can afford you. But on the other hand, a lot of people in academia do consulting in industry. So, you know, maybe you don't have to make a choice unless there's something that is in one of those that you absolutely don't want. Again, if you absolutely don't want to do teaching, then you can avoid academia. If you absolutely, I don't think there's any absolutes in industry or government, is there? just go into government and industry. It's just no, but I think you get my point. Being a combinatorial optimization person, right? I just feel like, okay, you have a decision. You just have to maximize your happiness with your job. So figure out your own constraints and understand what the contributing features are, and then just maximize.
And understand your biases as well, because I don't believe in people only doing optimization for decision, because you're ignoring your own biases. Be aware of
You
that.
can factor that into the model. That's stochastic
Once you,
programming.
these are
right?
the unknown unknowns, though.
Stochastic programming. It's good. We just
I had a question for Dr. Lacasse. I hope I pronounced that correctly.
Yes.
What does your current work involving partial differential equations look like? And to what extent would you hope that a potential candidate in your field had technical capacities in coding and programming?
Okay, so actually we ran a workshop at the IMA on partial differential equation as applied to something called full wave field inversion. So this is an approach where you use a joint state approach to extract the gradient of the wave equation. So what we're doing, we do an experiment where you collect, so you have an active source, you collect sound waves, and from those sound waves you're trying to invert for the material properties of the material. And this material for us is the Earth. And we can have sound waves, elastic sound waves that penetrates the Earth for maybe 5 kilometers and come back. And that's a way we can image the subsurface and understand the geology and see where the different formations are. And that's used for oil exploration. That's also used for water injection. And that's used for CO2 sequestration once we get there. So that's a very, we are continuing to work on this, and because there's also events that are called induced seismic event. I don't know if you're familiar, but if you produce oil, sometimes you cause small earthquakes, and to understand where they are and what kind of moment, so you have a moment tensor. And then the goal there is to extract the moment tensor from it. Again, you have the data, you're trying to invert for the material properties, the magnitude of the source, the moment tensor of the source, and then how do you regularize that? It's a very ill-posed problem. So it's an optimization problem. It's forward modeling. It's inverse modeling in terms of determining the gradient. So that's the type of skill that we've been working on, and that's what the workshop was all about. So we have several inverse problems. So they're not only forward. From a modeling standpoint, yes, you might need coding, but I think somehow, I don't think that's something that is specific to being a mathematician or a physicist, because you can say I'm a theoretical physicist, but at the end you'll need to be using Mathematica, or any engineer is trained, I think, from their childhood into Excel, sadly enough. So I think these are what we could call soft skills, but there's what math can teach you, and that's something we're trying also to address through I'm on the board of governor of the IMA, and we're trying to guide the program so that there's more soft skills in terms of if you think, for example, even if you're in academia, once you become the dean of a faculty, you don't need math anymore. There's a much broader skill set that you need to acquire. Or the fact that Phil organized this or created this baby here, the Math Alliance, that's not a skill math. That's not the math skill. That's really how to understand how individual works, how the society works, having a vision and the desire to address it. So I don't think that's, if you go to either the industry or academia, I think PDEs is one thing. I mean, you're looking for specific skills in terms of PDEs, but I say you need to also be very open into how do you acquire those other skills? How do you acquire the skill to understand the people around you, address those problems, and have them create the momentum and to go and once you identify a solution, to implement that solution. I don't know if I answered your question or not.
Oh, hello, everyone. Good morning. My name is Jada.
Good afternoon.
I know. I say good morning, afternoon, and night. But My name is Jada Rice. I am a senior mathematics major at the Texas Southern University in Houston, Texas. And my question to you all is, what differences would you have made to get to where you are today? If you could talk to your younger self, you might hear this question a lot, and then I have a part 2 question after. Oh, part 2 question. Okay.
I don't think you want to ask the part 2 first, or no?
Okay. And then my part 2 question is, what is your major advice for someone who is about to graduate? They're afraid of the big world. I understand all of you would recommend going into the industry, but what exactly would you recommend we do as a freshly graduated student?
Are you going to graduate school? Theoretically. Okay. So, for me to be where I am, I wouldn't have made any changes. And it's somewhat serendipity, somewhat divine. Depends on what your worldview is. But yeah, like I said, I chose math because I couldn't figure out what I really wanted to do, and I knew that math was flexible and easy. Right? So a lot of you chose math because you took some math classes and you were like, hey, I really like this a lot more than I took those other classes. So I would say kind of, especially if you're still in school, take classes that you like. Obviously take some other classes because you need that diversity of thought. But, you know, if you find yourself continually taking applied classes, so to speak, right, then you probably want to go in that direction, more application focused. And so I took linear optimization, nonlinear optimization, mathematical modeling, numerical methods, and I just took them because they looked interesting. And so when I was going to graduate school, I thought, I should probably look for an applied program. And so, yeah, so then when I was going to graduate school, I thought, well, I'll just keep doing this until I figure out what I really want to do with my life. I taught for a while. I really enjoyed teaching, but it wasn't scratching the itch. And so then I went to government. And I could see myself, like, I really like teaching. So I could see myself no longer adjuncting and just saying, okay, I'm going full speed back into academia. But ultimately, I think there's something that you really enjoy. And you may know what it is, but you might be afraid to just follow that passion. I'd say follow the passion. If you're graduating and you're not quite sure what you want to do, there are several organizations that have internships for graduating seniors, or for people post baccalaureate. So you might try an internship and find out, do I really want to do research? Or do I want to do something in industry? There's still time. I wouldn't say necessarily go back to school because, especially if you're not in a PhD program, you could end up spending lots of money and still not know what you want to do. But I'd say, if you're not sure about graduate school, get a job, right? Graduate schools accept people every year who are coming back from industry, right? So give it a shot, see if you like it. And if you like it, then great, you made a great choice. If you don't like it and you're really missing the research and really missing the academic setting, then it's not too late. I'd say it's never too late to change your mind.
Okay, I think your question has the hidden assumption that there's translational invariance between what worked for me and what could work for you. And so I would never give you advice about things that I thought worked for me, but I never know because life is a one-shot experiment. And if I were to compute the Lyapunov exponent in my own life, it's pretty hard. It's pretty high. So the butterfly effect, there's some tiny things that you do in your childhood, somebody that you met or something that you've done that can change the course of your life pretty dramatically. And I think we need to accept this. It's good to have a plan. It's even better to break those plans, right? But at least it gives you a direction what to shoot for, and it's a guiding principle, but you should not adhere, I think, too strongly to those plans. And then your second question was about, so the first one was what worked for me, for us, or
Right.
what didn't work. I mean, this list is much longer if you have time. And your second question was? I think your best bet is having an industrial postdoc. And that's a program that existed at the IMA until, I think, still continues to exist. And there's some other places where you can have an industry. So once you're in grad school, and if you're not sure, okay, I want to go to academia versus non-academia, I would say take an industrial postdoc position. IBM offers them. We offer them at ExxonMobil. The national labs is a good place because the national labs in the U.S. are really at the border between applied science, applied mathematics, applied physics, and also they're very well connected with the academic world, and you don't have to teach. But that's a good way to put your feet in the water of the industry without being afraid to if you don't swim good enough. No.
I think she's a bachelor's degree, right?
So your bachelor degree?
Your bachelor's degree? Yeah.
If you want to go to academia, you'll need, I don't think a PhD. Well, if you want to do teaching, and then there are people much better qualified than I am. Or I'll do, maybe I do what Richard did. I should probably write the book, How to Get a Job in Academia.
You and I can partner on that.
So now we can partner and do that.
So as to your first question, advice to my younger self, I'd probably advise myself to get out of the math department more and talk to people from other science departments, from other engineering departments, from humanities departments. Just find out what people are thinking about, what people are doing. Part of the training process in mathematics, you go to graduate school and you get very narrow. You learn how to do things and to think in a certain way that very few other people in the world, percentage-wise, can do. And that feels great for a while. But then you realize, wait a minute, all I know how to do is this. It's very narrow. So it's good to stay broad and maybe get involved with other grad student groups if you're in grad school, meet people from outside your own field. Find out what they care about. Find out what the burning questions are in their area. And it may lead you to some research questions, or it may just enrich your life in a general way. Another advice probably is to think about the power relationships and in the institutions that you're a part of and more generally in society. And I'm sure a lot of you in the room are sort of very aware of historical trends and changes in this organization. The Math Alliance is trying to change US, North American society in good ways. So change doesn't just happen. It happens because people try to make it happen. So you can be a part of that in whatever way you think you can. I think I'd advise myself to be more intentional about trying to acquire mentors. So I had my PhD advisor when I was in grad school. That was good. But I didn't really do much in particular to get to know the other faculty members, and I could have done more. When I became a faculty member, I had one idea, which seemed to work pretty well. I'd invite someone different every week to meet for lunch. And so that way I just got to know people, and the payoff might have been 10 years down the line. One case, I went for lunch. He was a number theorist. He basically asked, well, why do you want to have lunch with me? And I said, well, I just sort of want to get to know what people are doing. And then 10 years later, when I was grad director, I needed someone to help run a small REU program. And he was just the guy for the job, and he jumped at it. So getting to know people. I'd also advise myself to be less self-conscious, and that plays into what you do at conferences too. So you're standing around, you don't know anybody, you're not talking to anybody. Just go up and talk to somebody. I mean, really, what's the worst that can happen? So, okay, that's all the advice to my younger self. Advice to someone about to graduate, reflect on your values, right? So what matters to you? What's going to make you feel like you're living a meaningful life? And follow that. You can't listen to what other people think you should do, or what you ought to do, or even what your training suggests you ought to do. You really have to start from what's going to feel meaningful to you. At a more practical level, you can ask yourself, are you people-focused? Do you like helping other people develop their skills? And in that case, academia is a great place because you spend a lot of your time helping other people, mentoring people. You get paid to do it.
I do that too.
But
Me too.
But maybe a more sort of an internally focused problem solver who likes to be sort of more of a backroom person, and then you should perhaps choose a different career path, find the right one for you. If you do go to graduate school, I think broadly about the field you go to. So everybody here likes mathematics, but mathematics can sort of lead you in many different directions after undergraduate. It's quantitative fields, finance fields, engineering fields. Mechanical engineering departments love to get math students, for instance, into their graduate programs. Data science, of course, statistics, information science. So you can go many different directions. So just because you've been a math major as an undergrad doesn't mean you have to go to grad school in math. In fact, most of our students at Illinois, undergraduates, who go on to graduate school, do it in a different field, not in mathematics. And I don't think that's a criticism of our program. I think it's a testament to the fact that they feel they've got the right kind of skills to go in some direction now that interests them, now that they've figured out what they're really about as a person.
Hello, I'm Andrew Betts from the University of Alabama in Huntsville. So I have a question. I'm a second-year grad student about to finish my master's degree. So I have a question. I've always been interested in industry. Whenever people would ask what I want to do with math, my first answer is I want to do industry and research in like a private or government kind of sector. So that's what I really want to do. The things that are worked on in those kind of environments interest me. But the question is, how far would you recommend going? Like, is a master's degree for industry, is that good? Is a PhD, would you recommend that? Or like, and I think that something that is useful for everyone to hear is if you're one of those math people who do want to work in industry, what would be a good benchmark, I guess? Or is a PhD worth pursuing if you know you want to go into industry?
It seems like you're trying to solve an optimization problem here. So you want maximum results with minimum effort.
That one's truly stochastic. Like there's
as I said earlier, I think it depends on the position you're applying for. Usually from a research perspective, we tend to draw the line at the PhD level for any research position within the I think within all the research organizations. Let me tell you a little bit what we do. So I'm in a lab. We hire about 160 PhDs, and they're from all sciences, and we're something called Corporate Strategic Research Lab, and we're looking at all problems as related to the upstream, which is exploration, production, and development of oil fields. We're looking at the downstream, which is refining and supplying new products, and then also chemicals, which are polymers and so on. We also look at the corporate programs, which is I was mentioning earlier, like climate change, carbon sequestration. So for all these fields, if you want to be leaders in the world and try to come up with solutions and interact with universities, we tend to hire people that would have a PhD for research. And one of the principal characteristics we're looking at is the ability to do individual, non-directed research. And that's really the key point. So if you want to get into a research lab where you do individual research, undirected, and where you need the full latitude to define your own project, so you need to have a sense of maturity that only a PhD and possibly a postdoc could provide you with. If on the other hand, you would like to be in a more business-oriented, where you're interacting with the business partners, but you still need to have a basic foundation in either statistics or basic math and critical thinking, then those positions will tend to be much faster paced, much closer to the business, and sometimes even better remunerated. If that's, I'm trying to optimize your equation here. And that's something that you need to look for. There are areas where your sense of business and your willingness to take on hard problems might pay off. And maybe one way to complement this with a business degree or have classes and more into business. So where you marry both your critical thinking in math with skills that are immediately applicable to a fast-moving business. So that would be my advice.
Yeah, my answer would be it depends. That's kind of the general answer. I'd say start thinking about the kinds of jobs that you might like and the companies that you might like. Not necessarily that you'll work at those companies in those jobs, but go online, read the job descriptions, read the requirements, find out what they are, and you'll find that the majority of them do require a particular degree or a particular set of skills. And this is good for anything, whether it's going into academia, going into Research One, going into undergraduate research institutions, going into undergraduate teaching institutions. Look at the job descriptions and look at the job requirements. Figure out how you can kind of point yourself in that direction, recognizing that there's a whole lot of variables that you can't control. So we hire mathematicians, we hire undergraduate, masters, PhDs, because we know that nobody knows what we do. And so everyone gets hired into a development program, and it's kind of after 3 years, you're full salaried and fully employed, but we give people 3 years to kind of figure out where they fit best. And I'm in the research directorate. Probably 90% of my team has PhDs, but we do have some people who don't have PhDs because going through the development program, they've kind of developed the ability to do this kind of independent, self-directed thought. And so it's kind of like getting a PhD without any paper, except for the paycheck. So it really kind of depends. You got to do the research. We can't sit here and tell you if you want to do this, do these things. If you want to do this, do these things. And then you might have that great plan, and then ultimately find out you messed up.
You always end up in an optimum, but you don't know if the global optimum exists or not.
So I'll just suggest one specific kind of employment you might look at, maybe after the master's. This is the National Lab System. So there's a whole network of national labs around the country. If you don't know anything about the national labs, just Google National Lab list of and see what comes up. They are, I think they're all under the Department of Energy. Some are nuclear weapons and nuclear energy focused. There are others that are not at all. So there's a wide variety of different kinds of work they do. The large employers, so Sandia National Labs, for instance, has about 5,000 employees, a large number of whom have PhDs, and all the labs are like that. So you might go work there for a couple of years, see how you like that kind of work, which is sort of government/industry. There are sort of elements of both to it. And that might also tell you, hey, I like the kind of work people in this group are doing. What would I need to do to get in at a higher level there and do a PhD in that area? So, just sort of give yourself a bit more information if you're not sure about the decision that you have to face.
I'll throw in that one of my bosses who just retired on Wednesday in the research directorate did not have a PhD. And so you really can't prescribe do this and you'll get the job that you want.
Hi everyone, my name is Stephen Lawrence, and my question is, how often should you participate in startups, also while working full-time, doing what you do, and also or how do you find yourself? You kind of answered it with your comment, but kind of find yourself in a company where it's not just you working for someone, but also being invested into the mission and plan of the company.
You trailed off at the end. What was the last part?
Or instead of just going off onto startups or starting your own thing, how do you kind of find yourself in a company where you're not just working for someone, but kind of a part of, invested in it?
So if I can rephrase your question, I think you're asking, how do you find a company that you can be passionate about? You just try a bunch of companies, and when I was in an academia, I really thought that that's where I wanted to be, and I happened to be visiting Rice, and one of my professors said, Bill, you've got the next 30 years of your life. You could spend 30 years trying to make this work, or you could change jobs and it might be exactly what you want. And I thought, he's got a point. It's nothing really lost. So I changed jobs and it turned out to be exactly what I wanted. Does that mean that I'll be at the NSA forever? Not necessarily, but every day, when I find something that I want to do more, then I'll change. But until then, I'm really passionate. If you couldn't tell, I'm really passionate about NSA and all the opportunity that's there. So I don't know if that answered your question. you never know, right? You think you want to work for some company, and you find out that it's not what you thought it was. You think you didn't want to work at one place, and you find out you love it. So.
Yeah, I don't know if I understood your question correctly either. So I've heard the word startup, and if you have an opportunity to play in a startup, by all means go, and you're going to do. I know a few people that were involved in startup, and that involves everything from being your own admin to do all the work and cleaning the toilets. I mean, because you're three guys in the company and you need to make it work. And so that's going to be, I think that's a very good way to learn everything from soup to nuts into a product. Your chance of success, is going to be very limited, and the numbers are showing this. But I think in terms of learning experience, if you have a chance, I would say go ahead, knock yourself out. That's the only time in your life you'll be able to do that as well. If going back to the comment about what specific job, I think there's a misperception that once you go to the industry, you're being put into a small box that is very, very tiny, and then you do the same thing forever. I think the more, and I'm going to advocate for the PhD again, I think if you have a graduate degree, that opens the possibility, the mobility within the company becomes tremendous. Yes, if you come with a bachelor degree in most industries, you will tend to be more limited because the skill set that you would fit, it's not true it's certainly true for the company I'm working with, or for, depending on the day. But if you have a lower degree, you'll tend to be more, your mobility will be restricted somehow, not always, but somehow. On the other hand, if you have a higher degree, and also you have skills that you acquire all those soft skills, you will obtain tremendous mobility. I mean, personally, I've worked from anything from molecular modeling of polymer interfaces to granular systems to wave propagations to an inclusion and diversity committee and recommendation. So I'm doing all of the above and mentoring, and I've been involved in hiring for the last 15 years. And I'm also interfacing with many different universities and research projects for which I advise. So in order to get there, the only thing you need is your experience, the way you develop, because it's not that you go to school and you stop there. As I said earlier, in most of you, once you get to a certain level, you keep on learning. You just establish, you got your ticket learner punch through school, but either you stay in school or you go somewhere else, you're going to continue to learn. So don't think that you plateaued somewhere. It just keeps on going.
So Stephen, right? Yeah. So I'm going to paraphrase your question. I hope it's in the ballpark of what you're asking. How do you find a company where your contribution is going to be valued? That's maybe one way of thinking about what you're getting at. Networking, obviously, before you go work somewhere, you want to find out as much as you can about that organization. Informational interviews, that's something that's not been mentioned much up till now, but as part of your networking, you find somebody working at a company or in an industry more generally that you're interested in, find a way, make some kind of contact, find a way to get and talk to them on the phone or in person, 15 minutes, half an hour. You don't want to take too much of their time. You're not asking for a job, you're just trying to find out what's it really like to work in that industry. And what advice do they have about different companies and organizations in that industry? And then, of course, you'll go someplace and you'll find it's not quite what you want for some reason. So I'm thinking of one of our PhD graduates who went to work for a large insurance company in their research group in downtown Chicago. But it turned out, even though the job was great, the view was fantastic, the perks were terrific, he didn't really want to live in downtown Chicago. And so now he's living in, I think, Boulder, Colorado, working for a completely different company. And in fact, he's working remotely. So now he gets to work in his pajamas and set his own hours and so on. So he had a good first step. It taught him something, and then he moved to something that fitted him better. And so it's fine to take a job, do well at it, treat the people there well, move on to something else when you figure out what you really want to be doing.